Hello friends, Mr. Burrell here. We're in Unit 3. We've been talking about parallel lines, some of the relationships that exist with the angles in parallel lines when I have a transversal cutting through. We've talked about what some of those relationships are called, what we call some of these different angle pairs, if they're congruent, if they're supplementary. We've talked about solving different kinds of problems using those relationships. Now we're going to kind of sidestep just a little bit. We're going to talk about logic statements. In the end of this unit, we talk about proofs of parallel lines. And logic statements, understanding what logic statements are and how to use them, are going to help us with that. So by the end of this lesson, we're going to be able to define conditional and converse statements. We'll talk about what those mean. And then given some statement, I'll be able to write its conditional and converse statements. So we are kind of blending the English and math classes together today. Some places where logic statements are used a lot, if any of you go into like computer science or computer programming, things like that, they use conditional statements a lot. A lot of the math associated with computer programming has a lot to do with conditional logic statements. So, let me give you an example. So this statement here, it says, if it snows 4 feet tomorrow, then they will cancel school. Do you think that is true? If it were to snow 4 feet tomorrow, do you think they would cancel school? It's very probable, right? It's very possible. If it snowed 4 feet, like the buses wouldn't even be able to get out of the parking lot, you know? If it snowed 4 feet tomorrow, they would probably cancel school. That would probably be true. Sure. Yes. Okay. Now we'll take a look at this statement. This statement says, if they cancel school tomorrow, then it will snow 4 feet. Do you think that is true? If they were to cancel school tomorrow, that would then cause it to snow 4 feet. I don't think so. Just because they cancel school does not mean it's going to snow 4 feet. The reverse of that would probably be true. Like if it snowed 4 feet, that would probably force them to cancel school. But them canceling school would probably not force it to snow. Okay. So let's take a look at this question. This is probably more along the math realm of what we've been talking about. If two lines are parallel with a transversal cutting through, then alternate interior angles are congruent. So if I have two parallel lines like so, then are these alternate interior angles congruent, or are they the same? Is that true? Yes, it is. That's something we've talked about pretty recently. If I have two parallel lines and a transversal is cutting through, then alternate interior angles are congruent, or equal to each other, or the same. Okay? Now take a look at this statement. If a transversal cuts through two lines, so if I have just two random lines, if I have two lines, and I have alternate interior angles that are congruent, so I don't know these are parallel yet, but if I just tell you, if these two angles are congruent, the alternate interior angles, are those two lines parallel? Yes. In this case, the same works both directions. If the lines are parallel, then the alternate interior angles are congruent, and same in reverse, or conversely, if the alternate interior angles are congruent, then the lines are parallel. Works both ways. So, that kind of leads us into what we're talking about with conditional statements. What is a conditional statement? I like this meme. I don't always make conditional statements, but when I do, they become memes. Anyways. So, a conditional statement I also will sometimes call an if-then statement. So, a conditional statement includes a hypothesis and a conclusion. It is an if-then statement where P is the hypothesis and Q is the conclusion. In other words, if this is true, so if something, whatever it may be, if this is true, then that is true. So if my hypothesis is true, if P is true, then this conclusion is true. This Q is true. So if P, then Q. If this happens, then this happens. If this is true, then that is true. Okay? That's a conditional statement. It's just an if-then statement. So for example, this is an example of a conditional statement. If you step on a crack, step on a crack, then, there should be a then here probably. If you step on a crack, then you will break your mother's back. Have you heard that phrase before? Don't step on a crack, you'll break your mother's back. That's a conditional statement. If you step on a crack, then you'll break your mother's back. If this, then that. If P, then Q. This Q statement is conditional on this statement. If I step on a crack, then I'll break my mother's back. Okay, so that's a conditional statement. The other kinds of statements we're going to talk about are converse statements. A converse statement is the reverse of the conditional statement. So watch this. In this same, let me go back to this conditional statement. If you step on a crack, then you'll break your mother's back. The converse of that statement is if you break your mother's back, wow, that's good English. If you break your mother's back, then you'll step on a crack. So notice how my hypothesis and my conclusion just switched places. Before I had if you step on a crack, then you'll break your mother's back. There we go. This time I've just swapped them. So if you break your mother's back, then you'll step on a crack. So conditional and converse statements are just like inverses, reverses of each other. Okay? So will a conditional statement and its converse always be true? What do you think? Will a conditional statement and its converse always be true? Well, let me give you an example. So here's this general statement. All giraffes have long necks. So here's a conditional statement. If it is a giraffe, then it has a long neck. Do you think that's true? Yes. All giraffes have pretty long necks. So that conditional statement is true. If it is a giraffe, then it has a long neck. Well, let's look at its converse statement and see if it is also true. If it has a long neck, so just any animal, if it has a long neck, then it is a giraffe. Is that always true? Well, no. There's other animals that have long necks, like flamingos is one example. So that converse statement would be false because it's not true. Just because it has a long neck, just because an animal has a long neck, does not make it a giraffe. Okay, so sometimes both the conditional and converse statements will be true. Sometimes one will be true and one will be false. Okay, here's just some random comics associated with conditional statements. If I study, I will pass. If I studied, I would pass. If I had studied, I would have passed. I think a lot of people have those kinds of thoughts as they're preparing for tests. Jeremy, if you're going upstairs, could you bring these up and put them in the hall closet? If I'm going upstairs? You were going upstairs, weren't you? Not if there are conditions. See? Anyways, so those are conditional statements. So let's look at some examples. This is what your homework might look like. So I'm going to give you a sentence, some sort of statement. You're going to have to write a conditional statement and a converse statement. Okay, so example 1 here says 2 parallel lines cut by a transversal, like this. 2 parallel lines cut by a transversal have a set of congruent alternate interior angles. Okay. So, we're trying to identify here, first of all, what's the condition? What's the hypothesis? And Q, what is the result or the conclusion? So my condition, my P here, is that I have 2 parallel lines cut by a transversal. So I have 2 parallel lines cut by a transversal. And I use those like double train tracks to represent parallel lines. So that's my condition, that's my hypothesis. And I'm saying when I have these 2 parallel lines, the result is that I have congruent alternate interior angles. Congruent alternate interior angles. And this little like alligator jaw can represent an angle. So I know what my condition or my hypothesis is. I know what my conclusion is. So my conditional statement might look something like this. If there are 2 parallel lines cut by a transversal, then alternate interior angles are congruent. I'm abbreviating here to save me some writing time. That's my conditional statement. If there are two parallel lines cut by a transversal, then alternate interior angles are congruent. Okay, then my converse statement would be if I switch my hypothesis and my conclusion, if I switch my P and my Q. So the converse statement would be if alternate interior angles are congruent, reminder that here's like the little symbol that means congruent, the little equal sign with a squiggly over it, then the two lines are parallel. That would be my converse statement. Again, these two statements, the hypothesis and the conclusion, just switch places. Okay, here's another example. So example 2 says, I get good grades when I do my homework. So, first of all, do you think that's true? I think most people who do their homework do get pretty good grades. So my hypothesis, my condition, is that I do my homework. So the hypothesis is that if I do my homework, then Q, the conclusion, is I will get good grades. Okay? So my conditional statement will be, if I do my homework, then I will get good grades. Yeah? Yeah? I think so. So that's my conditional statement. It's just an if-then statement. If I do this, my homework, then this will happen. I will get good grades. So the converse of that statement, again, I'm going to just switch the hypothesis and the conclusion. So if I get good grades, then I will do my homework. If I get good grades, then I will do my homework. That one doesn't sound as realistic, does it? If I get good grades, then I'll do my homework. No, you have to do the homework in order to get your good grades. So this would be an example where the conditional statement is true, but the converse statement probably isn't true. Okay, let's do one more. There's some other examples in your guided notes that I'll leave for you. But example number 3 says, snakes are reptiles. Okay, that's a pretty simple statement. So the hypothesis is that I have snakes, so it's a snake. So if I have an animal that's a snake, the result is that it's a reptile. Yeah, if I have a snake, then it's a reptile. So my conditional statement would be, if it's a snake, then it's a reptile. Which is true, right? All snakes are reptiles. The converse statement would be found by switching the hypothesis and the conclusion, or the P and the Q, and I'd write, if it's a reptile, then it's a snake. Is that true? Not necessarily. Just because it's a reptile doesn't mean it's a snake. Not all reptiles are snakes. Okay, there's other reptiles besides snakes. So those are my conditional and converse statements. There's a few other ones here, but by the end of this lesson, again, now I hope that you are able to define conditional and converse statements. Remember, conditional statements are just an if-then statement, and a converse statement is found by switching the hypothesis and the conclusion. And then if I give you a statement, I want you to be able to write a conditional and converse statement. So that's all I have for you in this lesson. I hope that was helpful. Please don't hesitate to reach out if you have any questions whatsoever. And I hope that you enjoyed that as much as I did.